So in this section, we will talk about integration under several variables with different coordinate system. In our class, we have seen two different coordinate systems other than the rectangular coordinate system. These are polar coordinate system, which in three variable was extended as either cylindrical coordinate system or spherical coordinate system. This first example is an integration that is already set up for us, and it is in spherical coordinate system, where I'm going to take the antiderivative with respect to rho first, then we're going to take the antiderivative with respect to theta and then phi. So let's start working on this problem. Looking at the antiderivative, because there is rho square and rho cube, I decided to substitute rho cube equal to t. What does that mean? That means I'm going to take derivative on both sides and get 3 rho square equal to dt. 3 rho square d rho equal to dt. But I do have only rho square d rho, so divide both sides by 3. You get rho square d rho equal to dt over 3. What else? I have to change the limits from rho to t. Rho limits are 0 and 2. If you put rho equal to 0, 0 cubed becomes 0, so t lower limit is 0. If you put rho equal to 2, then you get 2 to the power 3, so upper limit for t is 8. So now I'm going to rewrite this antiderivative as 0 to pi over 2, 0 to pi e to the power minus t dt over 3 d theta d phi. And this new limit for t is going to be 0 to 8. So take this constant 1/3 out, and you get 0 to pi over 2, 0 to pi. If you do the antiderivative of e to the power negative t, you get e to the power negative t over minus 1 with the limits of 0 and 8. d theta d phi. Now recall, if I put t equal to 8, I get a constant. If I put t equal to 0, I get one more constant. So all of them I can take it outside. And what I get? I get minus e to the power negative 8. And I get minus of minus e to the power 0. And I still have the antiderivative 0 to pi over 2, 0 to pi d theta d phi. So I get 1/3. E to the power 0 is 1, so you get 1 minus e to the power minus 8. Integration 0 to pi over 2. D theta is theta within the limits of 0 and pi, d phi. So I get 2, the pi is also a constant, so I can bring it out and write it as pi over 3, and then 1 minus e to the power negative 8 times antiderivative of d phi, which is phi, so you get pi over 3 times 1 minus e to the power negative 8 times phi within the limits of 0 to pi over 2, which is pi over 2. So you get pi over 3 times 1 minus e to the power negative 8 times pi over 2, and that is pi squared over 6 times 1 minus e to the power negative 8. And that should be the final answer to my question.